This is a graph summary. We're going to graph 2x minus 3y equals 12 by hand and illustrate three different forms of equations. This is part of the Family of Functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. We have graphed lines whose equations have two variables in three different forms. The method that you use to graph a line depends upon the form of the equation. So let's have a quick review or summary of the three forms. So a times x plus b times y equals c is considered standard form. The best way to graph this one is using the intercepts method. Recall that the x-intercept occurs when the y-coordinate is 0. The y-intercept occurs when the x-coordinate is 0. Y equals m times x plus b. This is called slope-intercept form. The best way to graph, plot the y-intercept first using the coordinates 0, whatever b is. Use the slope to find at least two more points, and recall that slope is the change in y over the change in x. And the third one, y minus y sub 1 equals m times the quantity x minus x sub 1. This is called point slope form. The best way to graph, identify those three parameters, x sub 1, y sub 1, and m. Plot the point x sub 1, comma y sub 1, and then use the slope to find at least two more points. Again, the slope is the change in y over the change in x. Press pause as needed, resume when you're ready. So let's graph 2x minus 3y equals 12. The first thing we have to decide is what method to use based on what the form of the equation is. Pause is needed to decide and resume when you're ready. The equation is in standard form, so we're going to use the intercepts method. So I want you to pause as needed to find the intercepts. Resume when you're ready. The x-intercept occurs when y-coordinate is 0. So we'll substitute 0 in for y. 2x minus 3 times 0 is 0, so it becomes 2x equals 12. Divide both sides by 2 and we get x equals 6. So the ordered pair of the x-intercept is 6, 0. We'll plot that point, and then we'll go ahead and find the y-intercept, and that occurs when the x-coordinate is 0. Substitute 0 for y. 2 times 0 is 0, and 0 minus 3y is negative 3y. We'll divide both sides by the coefficient of y, which is negative 3, and we get y equals negative 4. So the ordered pair, 0, negative 4, we'll plot that on the y-axis. Now 2 points determine a unique line, so we'll go ahead and draw the line. Again, these are the intercepts. Pause is needed, resume when you're ready. Let's now rewrite this equation in two other equivalent forms. First, slope-intercept form, which is y equals m times x plus b. From the graph, the y-intercept occurs at the point 0, negative 4. And we know that the y-coordinate is the value for b, so b is equal to negative 4. From the graph, we can see that the slope is a positive number because as we read from left to right, the line is slanting uphill. We can draw in the right triangle, and we can see that the change in y is a 4 and the change in x is 6. And so the slope is the change in y over the change in x, or the rise over the run. 4, 6 will simplify to 2/3. So the slope, or m, is 2/3. And now that we have these two values, we'll substitute into the slope-intercept form, and we get y is equal to 2/3 x minus 4. This is the equation in slope-intercept form. Also, we could have solved the original equation for y, so let's go ahead and do that now. Pause to do so, resume when you're ready. First thing I would do is subtract 2x from each side, then divide each term by the coefficient of y, -3, each term. Simplify each of those expressions, and we get y is equal to 2/3 x minus 4, which is exactly what we got when we did it graphically. So you can find the equation graphically or algebraically. The third form is point-slope form. So go ahead and put this into point-slope form. Please pause to do so. Resume when you're ready. So we're going to select a point on the line, and we're going to pick one point that isn't already listed. So I'm going to pick this one. It's clearly on the grid at 3, -2. I'm going to go ahead and substitute these values into the general point-slope form, which is y minus y subscript 1 equals m times the quantity x minus x subscript 1. So we have the value for m, we have the value for the subscripted variables. Substituting those, we get y minus a -2 is equal to 2/3 times the quantity x minus 3. This equation is in point-slope form. Some people like to simplify minus a -2 as y plus 2. This also would be considered point-slope form. Press pause as needed. Resume when you're ready. We should point out that there are an infinite number of equivalent equations in point-slope form, and the reason for that, there's an infinite number of points along the line. So it depends upon the point selected for what equation we get. Other equations include, using the point -3, -6, you could have this one here. Or if you use a point 9, 2, you would get this one here. And again, there are several others if you extend the line out infinitely. Pause is needed. Resume when you're ready. Let's show that the point-slope form and standard form are equivalent equations. So we'll start with the point-slope form. We'd like to rewrite it in standard form. So pause is needed. Resume when you're ready. So the first thing I did was distributed the 2/3 throughout the parentheses here. 2/3 times 3 would be 2. And then I'm going to subtract 2 from each side to get y isolated. And we get y equals 2/3 x minus 4. This is the slope-intercept form, but we want to show that it's also the standard form. So I'll copy that back up here. Remember, you can pause the video anytime that you need to. Next thing, I'm going to multiply each term by 3, or each side by 3. 3 times y is 3y. I'll distribute this 3 here on the right side. And we're going to be left with 3y equals 2x minus 12. Subtracting 2x from each side, we'll get this equation. And this, we can take the opposite of each term and get the 2x minus 3y equals 12. So we've shown that the point slope, the slope-intercept, and the standard form are all equivalent equations. By the way, either one of these two equations is considered in standard form. The second one is sometimes preferred just because the leading coefficient is positive, but there's no set rule on that. Either one of those would be considered standard form for this line. Pause is needed. Resume when you're ready. So let's summarize this. Here's the equation an equation of this line in standard form. This is the equation of the line in slope-intercept form. And this is an equation of this line in point-slope form. So we've got three forms here. All of the equations are equivalent equations. They look different, but they represent the same set of points, so they're called equivalent equations.